This video will show you how to calculate the coarsening rate and interfacial energy using the property model calculator in the graphical mode of Thermo-Calc. In this example, we're interested in finding the coarsening rate of the carbide M23C6. The calculation is based on example number 11 of the examples listed on our website. To begin, open Thermo-Calc in the graphical mode and click on the property diagram template. We want to calculate a property diagram first to get good starting values for our property model calculator. We'll start by defining our system, so click on the System Definer. Beginning with Thermo-Calc 2015b, you can now store groups of databases as packages so that you can easily load multiple databases at once. Your databases are automatically packaged when you upgrade to Thermo-Calc 2015b, and you can create additional packages yourself. From the Package drop-down menu, select the Demo, Steels, and Fe Alloys package. This is a free demo package, so you should have it in your menu. It includes a thermodynamic and a kinetic database, which are both needed in the coarsening model. Next, we'll set our composition. If you already have your material saved from the previous video, click Load Material and select the ferritic file. If not, select the elements iron, nickel, carbon, manganese, and chromium. Iron is dependent, so we'll let that set automatically. Nickel is 1.4, carbon is 0.08, manganese is 1, and chromium is 17. This sets iron to 80.52. Now we need to configure our calculation, so select the equilibrium calculator. Notice that the composition auto-populated here. We'll use the default values for temperature, pressure, and system size, so make sure your values match mine. Also, be sure to use Celsius. We'll also accept the default variables for the axis definitions. Our calculation is now configured, so select Perform Tree at the bottom center of the program. Once the calculation is complete, a plot will appear in the results pane. M23C6 is represented here by the purple line at the bottom of the plot. I'll drag my mouse over the plot around 650 degrees so we can see it better. When I hover my mouse over M23C6, we can see that it is only a small amount of the phase. You can add a label to the plot by right-clicking on the line and selecting Add Label. I'll use the LaTeX format, so I'll write the phase name as capital M, underscore, curly bracket, 23, end curly bracket, capital C, underscore 6. When I click OK, a label will appear, and if I drag it away from the line, an arrow will attach to its reference point. We can see that at this temperature there is only one other phase present, BCCA2, so we'll use that in the property model calculator. When I hover my mouse over it, we can see that it is a large amount of the phase at this temperature. We're now done with the property diagram calculation, so right-click on the System Definer, hover over Create New Successor, and select Property Model Calculator. We're doing a coarsening rate calculation, so check the box next to the coarsening model. A tab will appear where we can define our conditions. In Thermo-Calc's Property Model Calculator, when you use the coarsening model, it will automatically calculate interfacial energy, so we do not need to select that model. Notice that the composition we set in the System Definer auto-populates here as well. We will set the temperature to 650 degrees. We'll set the matrix phase to BCCA2 because it was the other phase present at 650 degrees. We'll then set the precipitate phase to M23C6 because that is the carbide we're looking for. Next, we need to select our calculation type. We recommend that when using the property model calculator, you always run a single calculation first to make sure the calculation is valid. So select Single, then select Perform. The calculation will run in the event log. When it is done, the last line of the event log will say, "The sub-process completed normally." If the calculation worked, you will see the coarsening rate constant and interfacial energy. If the calculation failed, it will say NaN, which means not a number. If this happens, check your configurations for errors or try different starting values. We got two numbers, a coarsening rate of approximately 2.6 to the negative 28 and interfacial energy of approximately 0.267. So we know that the calculation was successful, and we can move on to a more complicated calculation. Select the grid calculation type. Set the grid definitions to mass % chromium and mass % carbon. For chromium, we'll set the minimum to 16, the maximum to 19, and the number of steps to 20. For carbon, we'll set the minimum to 0.06, the maximum to 1.2, and the number of steps to 20. Lastly, we need to add a plot renderer, so right-click Property Model Calculator, hover over Create New Successor, and select Plot Renderer. Click on the Property Model Calculator again, then click Perform Tree to run the calculation. Once the calculation is complete, your plot will appear in the Results pane. The default plot is a contour plot, where you can see how the coarsening rate varies as chromium and carbon vary. You can see the values of the coarsening rate at the right end of each line. You can also visualize the data as a heat map by selecting the Plot Renderer node, clicking the Plot Type drop-down menu, and selecting Heat Map, then selecting Perform again. The contour scale on the right gives you the value, and in this plot red is high values and blue is low values. Lastly, starting with Thermo-Calc 2015b, you can overlay plots on top of one another. You do this by adding additional axis groups to your plots. Simply click the green plus sign under the first axis group, and a second set of axes will appear. This can be done throughout the software. For instance, we can see it if we click on the Property Diagram Plot Renderer node. In the Property Model Calculator, we want to see the interfacial energy, so we'll select that from the Axis Variables drop-down menu. You can enable and disable axis groups by checking the box at the bottom of each group. For instance, we could disable the first axis group if we only wanted to see interfacial energy. We also want to see the coarsening rate, so we'll leave the box checked. Finally, the overlay only works with a contour plot, so we'll change the plot type back to contour, then select Perform again. Here we can see the coarsening rate coefficient represented by the blue lines and the interfacial energy represented by the red lines. To learn more about the Property Model Calculator, view the other examples videos we have available by clicking the links currently on the screen, or view our user guide, which explains how to set up calculations in all the models.